Here we go. We've got a trough. If you don't know what a trough is, we're going to draw a picture of it. It is 10 meters long, 10 feet long. 10 feet long. It's got an isosceles triangle. Wow, beautiful drawing. I'm going to become an artist and put my artwork on YouTube, and then, yeah, everything's going to be just like, wow. Okay, so we've got the triangles here on the end, our isosceles triangles. So that means this side and this side are the same. Tells us that it has a height of 3 and a base of 4. So this length is 4 and that length is 3. Vertices are at the bottom, so there's our drawing. Water is being poured into the trough at a rate of 3 cubic feet per minute. What is that? That's a rate of volume, right? So we know that volume is a function of time, and we know that dV dt is 3 cubic feet per minute. How fast is the water level rising? So what would that be called?
Rate of height.
Rate of height. So we know that height is also a function of time, and we want to find dH dt when it's 1 foot deep. So the next thing we need to do is we need to make an equation for the volume using height as the only variable. How would we do that?
Well, V equals base times height times width or length.
Okay? So yes, we can find out the area of the base of the triangle times by the length of the triangle will give us the volume. Okay? So our volume will equal the area of the triangle.
Base times length. Base times height divided by.
Base times height divided by 2 times by the length of the trough, which is 10.
And we know what the base is already, height.
Can you see right now, though, we have more variables?
We have a base and height. We know what they are.
Well, we know what they are when it's complete, but we don't know how it is as it's changing. We know the base of the thing is 4, but that's when it's full. We have to figure out how are the base and the height related all the way through so that we can have an equation here that only has one variable. This is the thinking part. How are we going to do that?
Why can't we put 4 in there? Steps.
Here's our isosceles triangle, right? Here's our base. Here's our height.
Radius 3.
This triangle right here, when we don't know, has to be similar to the actual big triangle, which has 4 here and 3 here.
But we do know that that one is 4 and 3.
No, we're looking for the water.
But we're looking for the water because eventually the water will be, ooh, pretty. Look at that. Artwork. Subscribe now. It's a little wavy. But this, because this water level here would be right here, right? There is a connection between the two. They're similar triangles. How are the height and the base related? The base is 4/3 of the height. No matter what size that triangle is, our base here will always be 4/3 of the height. Because in the original one, the base is 4 and the height is 3. And no matter how big or how small, because you have similar triangles, this relationship has to hold. It has to have the same relationship all the way through. So now we can go back to our formula, and instead of writing base, we can write 4/3 of the height. So volume equals 4/3 height times height. Can I just do the 2 and the make a 5 there? 10 divided by 2 for 5, so we don't have fractions and fractions. Is that okay? And if I multiply this all out, I've got my volume is going to be 20 over 3 h squared. Now we do the dHdt. So we're going to get, right, we're taking the derivative with respect to time of this whole thing. So we'll get dV dt equals 10 over 3, sorry, 40. Look at this, check it out. Oh, 40 over 3.
Oh, you scared me so much.
40 over 3 h dH dt. And we're finding it when the height is?
3.
When the height is 1, we want to find it, and dV dt is 3. So 3 equals 40 over 3 times 1 dV dt, dH dt.
Oh, you're losing it.
Quality's going down. I can go up a bit. And solving, we'll get 9 over 40 equals dH dt.
0.225.
0.225, what are our units? Our height was in centimeters. Someone have a look to see what the units were. Height was in feet. So now that we're looking for, this will be feet.
Cubic feet.
Not cubic, because we're just dealing with height. Height is measured in feet. If we're dealing with volume, volume is cubic measurements. Feet per minute is the change in height over the change in time.